Everything is clear. As I told you again, the exam is not going to be something from the beyond schedule. So whatever you have calculated, but it doesn't necessarily mean I'm just gonna copy and paste the questions to the exam. So you'll be given a similar exam to that point. Okay. If you don't have any questions, then let's start our lecture with duration gap, chapter 7. So as it was mentioned in chapter 8, we have underlined several times the weakness of the repricing model and its reliance on, when we calculate, and it's totally reliant on the book value rather than considering the market value of the assets and liabilities. So indeed, in most countries, financial institutions, they all report their balance sheets using their book value accounting standards. So this method records the historic values of the securities that was initially purchased, actually. Loans made, liabilities sold, these are the examples. And for example, in US banks, the investment assets, those that are expected to help until the maturity, like bonds, are recorded at its book value rather than market value. And we have another example, like assets that are expected to used for trading. Trading securities or available for sale securities are reported on market value. So basically, there are three ways of doing it. Like according to IFRS, it's not given in the book, but I'm just gonna share with you this information. So we have two different versus accounting standard. One is the IFRS, the other one is the GAAP. This accounting standards that recognize, that let the financial institutions or any institution to recognize their assets and liabilities. So the three things that you should keep in mind, like first, if investments are bought or sold with the purpose to held to maturity, like you will buy it and you're gonna keep it until the maturity, when it's matured, like bond with 20 years or 30 years. Then these type of things should be recorded on the book value. This is what the IFRS and the GAAP says, actually, on book value. So this type of asset, they should be recorded on the book value. So when we do the repricing gap, it really just consider this book value issues, and it really undermines the validity of it. So another thing is we call something for available, like trading, okay, securities. Trading securities on market value. On market value. But when it comes to available for sale, according to IFRS, you can record on book value, you can record on market value. But GAAP says you can record only on market value. So it changes. But basically, let's try, you can record on market value. So according to IFRS, it's more flexible. You can record it, you can recognize your purchase or sold investments on market or book value. So this is what it means. But the problem of the repricing model, it only does consider the assets or liabilities with the book value recorded. Okay, this is the problem actually of it. This is the main issue. So the recording of the market value means that assets and liabilities are remeasured or reevaluated, basically to reflect the current market position. Okay, it underlines currently what kind of what kind of financial position certain portfolio investment it has in the market. So example with if fixed coupon bond had purchased, let's say, for $100 per $100 face value in the low of interest environment. So if there is something that purchased for $100, let's say coupon bond purchased for $100, and with face value of $100, so any increase in the current market interest rate, that will reduce the present value of the cash flow. So once the present value of the cash flow reduced, definitely it's gonna affect the bond value itself. So bond value definitely will be reduced. The bond value will be reduced because of the interest. So such increase also reduce the price, and which the bond could be sold in the secondary market today. So the market value accounting approach in here, it will compensate it. So, but as we record in the book value, we will keep still the value of our bond to be equal to $100, even though the bond value will be reduced due to the increase in the interest rate. So the market value accounting approach reflects the economic reality, or we can say it is showing the true values of the assets and liabilities if financial institutions' portfolio is about to be liquidated at today's security price, rather than at the price when the asset and liability were historically or originally purchased for, actually. So this practice, like valuing the security at the market value, is referred as to marking to market. So whenever you hear something called marking to market, that means that the assets and or liabilities that has been purchased, they're reevaluated in accordance with the market value. So they're showing, they're reflecting the real picture of it. So that will be nice to make it. So imagine that how much if market value is shown this and suddenly the change in the interest, definitely the market value changed. That makes the book value to be deteriorated, actually. So this is the problem actually we face with the repricing gap, and to solve it, so interest sensitive gap management can be useful to this repricing gap, I mean, to protect against any interest rate changes. However, it does not fully take into consideration the effect of the changes in interest rate on the market that affects the bank's capital eventually. So you will see that the net worth, net equity of the bank will be deteriorated at the end. So additionally, the interest rate sensitive gap approach provides no single number to tell the bankers what their institutions are overall exposure to interest rate risk. Okay, they're talking in general, the direction and what will be the big change, but it doesn't tell any single number to the financial institution, like overall exposure to the interest rate risk. So to overcome these pitfalls, we're gonna talk and we're gonna learn how to calculate the duration of the bank assets and liabilities. So the concept of the duration is weighted average of the maturity of a promised stream of a future cash flow, like payment of stream to the bank that expected to receive from its loans and securities, or the stream of the interest payments that the bank must pay out to its depositors. So in effect, the duration measures the average time it requires to recover those funds committed to an investment. In a simple words, how many years, if you put yourself into the financial institution's shoes, then you will say how many years I need to have to cover my investment cost. So my investment cost is this much, and how many years I should earn money, in how many years I should earn the money to cover it. The less, the better the position of it. So it doesn't consider everything, the time value and the number of the years. It seems like kind of a payback rule. If you have taken any financial modeling courses like corporate finance, investment, or principles of finance, we have the NPV and investment appraisal stuff. There's a payback rule, but it's more or less close to it, but the way of calculating is totally different. We're gonna see it. So the general formula of the duration is summation of the cash flow times with a discount factor and times with the time, divided by summation of the cash flow times with the discount factor. That will give you the duration amount. So D represents the duration measured in years. CF represents the cash flow received on a security at the end of the period T, and represent the last period in which the cash flow is received. DF is representing the discount factor, which is 1 over 1 plus RT. So if you want to summarize, like we're taking the present value of each cash flow in the future that we're about to receive, time by the number of the years, and by the number of, not the year, by the number of the periods. It's better to say it like this, more correctly, because we are not only going to deal with the periods, not only with the years, we're going to deal as well with monthly basis, on semi-annual, and so on. So we're going to deal with the period. So summation sign. So this is summation sign that you have. You take the present value of each cash flow. So in first year, look, in year 0, we make some investment cost. In year 1, we receive 100. In second year, we receive 300. In third year, we receive $400. So you take the present value of each cash flow. Let's say this is 90. This is 280. This is 350. So what do? You just sum this all once you take the present value. You just sum it all. And you multiply with the corresponding period. And then you divide the all summed present value of future cash flows. Then you're going to get the duration of it, like how many years it is required to recover or to cover the investment cost. So suppose the bank loan is extended for 5 years, okay? The bank loans for 5 years, and it promises the bank annual interest payment of 10%, okay? There will be annual interest payment. There would be like annual cash flow during the 5 years, okay? We have 1, 2, 3, 4, and 5. Each year we're gonna receive annually same cash flow 100. So same 100. Sorry for my handwriting, but it's like the quickest way to just illustrate numerically on the kind of whiteboard. And the face value of the loan is $1,000. So this is what we should add it as well. So $1,000 in the 5th year as well. We're adding it as well. We need to discount it. So discount factor is 10%. Okay, we're gonna discount with the 10%. So here the discount factor is 10%. And this is $100 this is 10%, okay? And this is 10%. We are talking about the discounting, okay? We're discounting each cash flow. Then we take the present value of each cash flow, the summation, and we time with the 5, because 5 number of years. And then the same thing we do here, but without any multiplication with the time. We just divide it. And this will give you the number of the years that is required to recover the cost. The lower, the better the is actually. So everything is matter of the comparison with the benchmark is given. So for bonds that pays interest semi-annually or quarterly or monthly, here what you're gonna play with actually. This is where you divide, this is where you multiply, division, and multiplication, okay? This is where you work actually with. And here's the timing as well. You multiply with a time, not with years, not with the, so you should multiply by the corresponding period. What you are saying is like, Bejan, is I learned that duration also can be viewed as approximate percentage change of the portfolio per percentage change. We're gonna come to this point, okay? We're gonna come. You're so quick. Okay, that's really makes a good thing about it that you're learning everything in advance. Yes, we're gonna talk about it. Like we're gonna use it in a different manner, this duration, okay? Thank you, just raising this issue like you're trying to get everything in advance. So let's proceed with one example. There's a Eurobond that pays coupons annually, and interest rate is 8%. The coupon interest rate, the coupon rate is 8%. The face value of the bond $1,000. The current yield to maturity is 8%. Now, the calculation in the following slide. As the calculation indicates, the duration weighted average is equal to 4.99 years. We're going to discuss them. So the bond value, before coming to the calculation, the bond value is calculated if the YTM and the coupon rate is equal, then the bond value is equal with the face value. This is like the rule and the relationship we know from our previous classes, actually. Here with the question. So we said 8%. Here, this $80 is the coupon payment. Okay, this is the coupon payment. This is coupon payment. How we get it is 0.08, the coupon rate, times $1,000. That gives you the coupon payment. So we have 6 years, okay? We have 6 years, and all the payments are equally same. 6 years, okay? It's annually. It's not monthly, it's not quarterly, it's not semi-annual, it's annual. So every 6 months. So every year we have $80. But at the end of the 6th year, we have $1,080, which means this is the face value plus the coupon payment itself. So which is 1,000 plus 80. Then what we do, we get just discounted, and we discount by interest rate, which is 8%, like 80 divided by, let me give you 80 divided by 1.08 to the power 1, because from 1 year to the year 0, there's 1 year, so when we discount it, then this is same 80. It's just simple discounting, okay? 0.8 to the power 2, and so on. And this is 180 divided by 108. If you calculate how many years, 1, 2, 3, 4, 5, and 6. So divided by 108 to the power 6. This is how much we get it, okay? So this is the discounting factor, okay? This is how much we get it. Sorry, this is discounting factor. If you with discount factor, you have to multiply. But how can we get the discount factor? Is 1 divided by 108, okay? This number, if you want to calculate, but I showed you in a different way, you can get it like 1 divided by 1 plus 0.8. Okay, this is how you get it, this discount factor. And this is, you get it 1 divided by 108 to the power 6. 1,000 divided by 108 to the power 6, you're going to get 680. And then what do? You multiply everything. So we discount it. So this is discounted. Then what do? You have to multiply by time. So this $74 should be multiplied by period, which is 1. So this is what you get. 74 and here. Then 68, you multiply by 2. 63, you multiply by 3, and so on. So you multiply each present value cash flow that you receive in the future times by its corresponding period. And then at the end, you just sum it up. Sum it up. Then you divide it by the value of it. You get the duration of 4.993 years. There is another duration, 2-year treasury bond with an 8% of coupon and 12% of yield to maturity semi-annually. So the duration now is 2 years, like 2 years period, but semi-annually, and coupon payment is same. The only what is changed is the yield to maturity. That change in yield to maturity will change the discount factor. Okay. In previous case, we were dividing. So this discount factor, how they get it, is 1 divided by 1.12. Okay, this is how they get this discount factor. But in previous case, it was 1.08. But now they're getting in a different way. So in other way, you can get directly 40 divided by 1.12, you're gonna get this amount number. Or you just multiply with the discount factor. If you multiply 40 with the discount factor, you get this number. But then to get the last stage of calculation, the present value or discounted cash flow should be multiplied with the corresponding period, which is 1.5, 1/1.5. And that will be equal to 18.87. And same thing we do for all period. Why we have here 4 periods, even though in the question we are mentioned that it is 2 years. So if it's semi-annually, it means twice in a year. If it's 2 years, it means twice. If it's twice in a year, but in 2 years, it's gonna be 4 times. So 1.5, 1 and 1.5 and 2. So every 6 months. And then we calculate, sum all the discounted cash flows and time with the corresponding period. We sum it all, and we get 1,752. And now the discounted cash flow in the total, they are equal to 930. So in total, we have divided everything. We get the duration is 1.883 years. Now it's a semi-annually, okay? It's a semi-annually. Then we proceed. In this example, we have 2-year treasury bond with a 6% of coupon payment and 12%. It's still semi-annually, okay? If you compare with the previous example, it was 8%, but here now it's reduced to 6%. Okay? And one thing I forgot to tell you that it was 8% in here. Look, it's 8%. And please take attention to the coupon payment itself. So coupon payment is equal to 40. And we said the coupon payment is coupon rate times face value. So coupon rate 8% of 1,000, which is $80. That $80 should be divided by 2 because it's annually $80. When we divide by 2, we make it semi-annual, which is $40. So annual effect. So semi-annual effect takes the place when it's 40 from 80 divided by 2. Then we convert it into semi-annual basis. So same thing in here, 6%, the coupon rate with so we have 6% of coupon rate and YTM is equal to 12%. Same condition, 2 years, semi-annually, but only coupon rate reduced. Okay? If you look to the previous example, just remember this, is 1.88 3 years. Now, if the coupon rate reduced from 8 to 6%, okay, coupon rate reduced from 8 to 6. Look what happens to duration. Duration was 1.88 years. Now, duration is 1.90 years. So, reduction in the coupon rate, that increased the duration. That is not a good thing, okay? This is what you should take into mind, okay? Okay. So that means if you play with the coupon payments and the coupon rate, that will affect the duration. So we can conclude in here, there is reduction in the coupon rate will increase the duration. So there is an inverse relationship between duration and coupon rate. Inverse relation between coupon rate and duration. I'm just gonna put D, okay, just for simplicity. Okay, this is for this case, for the first case. When it was 8%, then it falls, it's a coupon rate, okay? And the YTM is same, okay? YTM is same. YTM is 12%. YTM did not change. YTM is 12%, did not change. So let's go further. In this table, the duration is 2 years same. Treasury bond with 8%, like we're assuming it's the same as it was like with 8 here. But what it changes, it changes only YTM. Now YTM falls, sorry, rise, YTM rises from 12% to 16%. That means that your present value cash flow will be reduced. Discounted cash flow will be less, though your coupon payment is the same as it was in the first case. Okay? So if this is the case, let's see what happens. Look, same number of the periods. Cash flow is the same with the previous, like here. And discounting the cash flow, what you can see, what happens, it reduced, and that if you divide it, you get your duration is equal to, so duration was 1.88. Now duration is 1.78. 878. Okay, years. So what we can conclude in here, I'm not moving to this example because it's not related to this first three, second, the third, and the fourth question. So in here, I can conclude that the higher the yield to maturity on the bond, okay? So once the yield to maturity increases, the more the investors they earn on reinvested coupons, and the shorter the time needed to recover this the initial investment. So the higher the YTM, the yield to maturity on the bonds, the more the investors earn on reinvested. They earn more on reinvested coupons, and the shorter the duration. So this type of, we can make conclusion on this. So once the YTM increases, that will reduce the duration. And that will make the investors to earn more money on the reinvested coupons. So in here we have same like inverse relationship as well with a rate. So basically with the rate, there is an inverse relationship and with duration, between duration and the rate itself. Now, let us go further. Okay, let me save it. With the last question, we can see that duration of the 1 year US Treasury bond with 8% and coupon is 12% yield. So what happens? If you reduce the number of the periods of the prepayment, that will reduce the duration. So when the maturity on the bond basically is reduced from 2 years to the 1 year, it makes to fall down the duration of that bond to 0.98 year. So the shorter the maturity on the bond, the more quickly the initial investment that you have incurred as a cost will be recovered. So we can say there is a positive association with the maturity of the bond and duration. And duration is what? Is the time is required to recover the cost. Is the time is required to recover the investment you made it, actually. So this is the summary. Like if coupon rate is 8% and the YTM is 8%, the 6 years annually, the duration is 4.93, but with the same coupon rate and with the higher YTM and with the less maturity, so we increase the YTM and we reduce the number of the years, but we kept coupon rate same. That by triple times reduced our duration. So there are two effects. One is the YTM effect. The other one is the maturity effect. As I told you at the beginning, that there is an inverse relationship between the YTM and the duration. As you increase the YTM, the duration will be going down. And of course, there is a positive association with maturity of the bonds, of the debt security. As you reduce the number of the years, that will reduce the duration as well. So there are two effects, but more effect comes from maturity itself. Then we proceed, like we reduce the coupon rate. And what happened? If you reduce the coupon rate, that increased your duration. So there's an inverse relationship between coupon rate and duration. Then what we did, we kept our coupon rate same as 8%, but we increased the YTM to 16%. And of course, that made duration to fall more to 1.878 years. And when the coupon rate is 8% and YTM is 12%, and it is reduced to 1 year, the duration falls even further. Okay, this is another example. I'm not going to go over it. Okay, let's talk about the net worth of any bank. So net worth of any bank is, simplest to say, is the net equity. Or how can we find it? Is the market value. Guys, look at here. It's very important here, okay? We know that how can we find the equity? The net equity is the asset minus liability. But in here, the net worth is reflecting the market value position, okay? We're taking into consideration the market value of asset minus market value of liability. So as interest rate changes, the value of the bank's asset liability will change, resulting definitely in the change of net worth or the owner's investment in the bank. So the portfolio theory in finance tells us that any rise in the market rate of interest will cause the market value of the bank of fixed rate asset liability to be deteriorated. So the longer the maturity of the bank asset and liabilities, the more they will decline in the market value. So when the market interest goes up. So the bank's change in net worth due to the change in the interest rate will vary depending on the relatively maturity of its assets and liabilities, okay? So we're coming to the position that we need to be very careful as a financial manager in the financial institution to match our liability with the assets, because interest rate change will affect depending on the maturity itself. My voice is getting bad now, sorry. Because duration is the measure of the maturity, a bank with the longer duration assets than the liabilities will be deteriorated greater than, and it will lead to a decline in the net worth if interest rate increases. So by equating the asset and liabilities durations, the management can balance the average maturity with bank's expected cash flow associated with its liabilities as a cost. So the duration analysis can be used to immunize, they call it like immunization, the market value of the bank's net worth when they match it. So there is another thing that we can see, like using the duration. Okay, this is duration to find out like price sensitivity of the security. It is one of the important features of the duration from a risk management point of view. It measures the sensitivity of the market value of the financial instrument to any changes in the interest rate. So the percentage change in the market price of an asset or liability is roughly equal to its duration times by relative change in interest rate that is attached to the particular asset or liability. So we are given an example here. So consider the bond and bank that carries the duration of 4 years. So let's say the duration is calculated. We're not calculating here. And the current market value is $1,000. Look, here they call the bond value is not the face value. And we know the face value is usually equal to 1,000, but in here the bond value is 1,000. And the market interest rate is comparable to bonds are about 10% currently. if market interest rate increases to 11%, what percentage change it will occur in the bond market value? So in this way, we'll be able to calculate the sensitivity of the price, like relative change in the price. Sorry, price of the money, it's we call it its interest rate, and divided by 1 plus the interest rate. So it was 10%, then it becomes 11%. And now we can see by how much it will affect the price of the bond, or we can say the market value of the bond. Here we always, guys, keep in mind we are having the negative duration in here, okay, negative number. So if the interest rate falls, and this will make us bring us a negative sign in here before the interest rate change, and that will affect the minus to minus, that will bring us plus actually. So using duration to hedge against interest rate risk, like if bank interested in fully hedging against interest rate fluctuation, then we have to use like dollar weighted duration of the bank's asset portfolio, which is equal to dollar weighted duration of bank's liability. So we need to immunize, we need to stabilize the durations. And when we take the difference between the dollar weighted duration and dollar weighted duration of the liabilities, we come up with duration gap. So in order to immunize, in order to stabilize your position, you need to make your duration gap to equal to 0. But you cannot make it absolutely, but at least try to bring it close to the 0. So when asset duration exceeds the liability duration, we have a positive duration gap, like with the repricing gap. That positive duration gap is equal to dollar weighted asset duration minus dollar weighted liabilities. So when the liability duration is more than asset duration, that logically gives us negative duration gap, and we have less than 0 the results. So the duration of the portfolio of the bank asset and of portfolio of the deposits on the liability side and other borrowings equal to the value weighted average of duration of each instrument. So it can be calculated in the following way. So we should calculate the duration of each loan, first of all. Deposit and similar. So we are calculating the duration on asset and the liability side. Then we are weighting each of these duration by the market values of the instruments involved. So we are giving the weighting value to each duration. Then third, we are adding all values weighted duration together to derive a duration of entire bank portfolio. Then we will be able to understand what's going on in the bank's position in the market value, in terms of the market value. Here's the formulation. So we evaluate the duration of each. So this is the duration of asset portfolio. So we give, we calculate our duration asset. We know how to do it. And then we give a weighting, and then we sum all these variables. We come up with the duration of assets, average duration of assets, we can say. Here's an example. We have a bank assets with the market values, treasury bonds, commercial loans, and consumer loans, real estate loans, and municipal bonds with the corresponding values, 90, 150, 40, 20, respectively, and with calculated durations. Durations, I mean how many years it required to come up to cover the investment cost. And their weighted average are already given, like 0.49, 0.60, 1.20, and 225, and 150 for each instrument. There is a specifically given weighted average. Okay, then we multiply and sum them all, and then we divide by the market value of each asset that we had. And we come up with a dollar weighted asset portfolio duration, okay, which is 3.47 years. And then we proceed with duration of liability portfolio. It is the same way calculate as the assets. W is representing the dollar amount of liabilities divided by total liability. And D is representing the duration of the liability in the portfolio. So in this way, we can calculate the duration gap. It's duration of asset divided by duration liability, the one we calculated now, the weighted averages, and times by total liabilities or total asset. That will give us a duration gap. Then there is a change in net worth. You remember the change in net worth we calculated in the previously. Okay, this is the example of how to calculate the change in net worth. It is duration of assets minus duration of liabilities. You remember how we calculate? This is how we do. This is assets and this is liability. So this is formula is more or less the same, okay? They carry the same meaning, but they are coming up with a change in net worth in terms of dollars, okay? So example we're given here, when we apply these formulas in complicated questions and more close to real example, real market example, then we're gonna understand better. We apply and we're gonna come with some certain interpretation like what does that result mean and what we should do in terms of hedging against any unexpected losses that may occur due to the changes in the interest rate. So we're giving some example in here, like suppose that bank has got duration of asset 3 years and duration of liability 2 years, and total liabilities is 100 with a total asset is equal $120 in terms of millions, and the interest rate originally was 10%, but suddenly increased to 12%. So what happens to the bank net worth? So we just substitute everything. The examples are really good ones. We can proceed at the end of the chapter. I think we're gonna start tomorrow. We're gonna go over tomorrow. So they substitute 2% is relative change. And as you remember, as I told you, like this part is very close to the price sensitivity. Okay. Here. Of security, okay. It can be price sensitivity of asset and price sensitivity of liability. So price sensitivity asset times 120 million of liabilities, and so that means that net worth of this bank declines by 2.91 million as a result of 2% increase in the market interest rate. So in here we can measure the change in net worth. It gives you more realistic picture against in comparison to repricing gap model, like we discussed the book value, because repricing gap model, it does consider only the historical prices of the instrument that it has been purchased or sold as assets and liabilities. But when you compare with the duration gap, and it really does consider the market value of the assets. This is the main advantage of it. Okay, I would like to stop in here. Tomorrow I will review it again quickly and we'll start solving questions. The more you solve, the better you understand actually the topic itself. If you don't have any questions, see you tomorrow. If you have questions, please feel free to ask. Okay, if you don't have any questions, see you tomorrow then.
Thank you. Goodbye.
Goodbye.
Bye. Take care.
Goodbye.
Goodbye. Thank you.
Bye. Bye. See you guys.